Okay, so let's finish off with example D. Example D asks us to prove that QP is parallel to SR. So this symbol here in the middle means parallel to. So let's write down our goal. Our ultimate goal is we want to show that QP is parallel to SR. Well, where is QP? Well, this line is QP and SR is this line. So what else can we see in the diagram? So QP is part of a triangle and SR is part of another triangle. Now that gives us hope because we know the sum of angles in a triangle are 180 degrees. And in fact, if we know that they're isosceles triangles, then we know that the two bottom angles are the same. Do we know they're isosceles triangles? Well, yes we do, because see here how they've got dashes there for the QP triangle. So that tells us that this triangle here is an isosceles on the left. This left triangle is an isosceles, which means that if we label the two bottom angles A and B, then A and B are the same angle. So we know that. And then what about the other triangle involving S and R? Do we know anything special about that triangle? Well, in fact, we also know that this triangle is isosceles as well because the dashes there indicating that the sides are equal length, which then means that these two bottom angles, which I'll label now as C and D, are also the same size angle, right? Because that isosceles triangle rule. So let's start our proof by defining the angles that we labeled. So let A, B, C, D be the angles, as shown or labeled on the diagram. And then we said that angle A is the same as angle B. Why? Because of isosceles triangle. And we also said that angle C is the same as angle D because it's also an isosceles triangle. Okay. You also notice on the diagram that there's one more symbol that we haven't highlighted yet. There's this arrow, right? So that tells us that this line, yellow line, is parallel to this other yellow line. Yeah. Now, if we connect these two together, we can see that angle A and angle C lie on these yellow lines, and together they form an F shape, which means that angle A is the same as angle C because of the F rule, the corresponding rule. So we can also say that angle A is the same as angle C because we're told about the parallel lines and they form an F shape, so it's a corresponding rule. Well, we know A means B and C is D, so if A is C, then that tells us that B and D are the same. So therefore, angle B is equal to angle D. So wait, how does angle B and angle D relate to each other? So let me just highlight that. So angle B is this one, and angle D is this one. So how do they relate? Well, let's highlight the lines touching angle B, which is that. And then highlighting the lines touching angle D is that. It's a backwards F, right? If you turn your head around, it looks like an F shape. So that tells us that these two angles are the same and they form an F shape. So using the reverse corresponding or the reverse F rule, that tells us that these two lines, QP and SR, must be parallel, because for the corresponding rule to hold, the lines must be parallel. And the corresponding rule holds because we can see that these two angles, B and D, are exactly the same. So since B equals D, then therefore QP is parallel to SR, because working backwards from the F rule, the corresponding rule. So we have achieved our goal, which is to prove QP is parallel to SR. So it looked scary initially, this proof, but it's actually not that bad once you write down what you can observe and any patterns that you know of. So a general hint with all these proofs is make use of the typical angle relationship of supplementary angles add up to 180 degrees. So angles lying on a straight line add up to 180. Angles in a triangle add up to 180 degrees. You've got especially the isosceles triangles where the two lines are the same distance and the two angles are the same magnitude and size as well. You can also make use of the parallel line angles, whether it's the F rule, the Z rule, or the U rule, the co-interior, the corresponding, or the alternate angle rules. So combining these different angle patterns, you can prove different statements in these geometric shapes.